Hey guys, we're going to go over properties of logarithmic functions, and the first one that we'll start with is the product rule. And I tried to color code it to be able to help you to visualize it, and it is rather simple. I have this logarithm, log base a of m times n, Mike times November, and I can simply rewrite that as a sum. I can say log base a of m plus log base a of n. And in most of these, whenever you have to do them as homework problems, your conversions is really not about finding a numeric value. If it's possible to be able to type it in and find a numeric value, you can check both of those. You can take this and see if it equals this. But generally what they'll give you is just some variables in there. So, example, express as a sum or a product, however it's given to you. So the first one is giving us a multiplication problem inside. So I'm going to rewrite that as a sum. So I have log base 4 of 64 plus log base 4 of 1024. And then you can convert it and be able to solve the value as 8. And if you were to turn around and multiply these two together and then find what that value is, log base 4 of this product, the value would be 8. But most often what you're doing is you're just simply writing this. Another example, as we can see, we have variables in here, so we're just going to take this sum of logs and rewrite it as a product. So log base 2 of x times t. Log base 2 of x times t. Alright, pause the video and see if the answers that you get for 3 and 4 are the same that I get. Alright, for my first example, I have the natural log of x, y. And that's the same as saying x times y. So I can write this as a sum, and I can say the natural log of x plus the natural log of y. And these two are equivalent. The next one is there's a product inside the parentheses there. So I can take this and break this into a sum. I can say log base 2 of 8 plus log base 2 of 64. And guys, that is your product rule. Most often the way your homework problems will be given is they're going to give you something in which you're going to turn around and break it into a sum of your logarithmic functions. The next one that I would like to look at is the power rule. This is our formula for the power rule. So I have log base a of m to the p power. And what that says is I can take that power and I can pull it down in front. So all of this is equivalent to p times the log base a of m. And what it'll probably ask you is to express as a product, meaning you're not going to find a numeric value for this. But I went ahead and wrote it out so that way we could see it. So this is my problem. I have log of base 4, or log base 4 of 2 to the third power. Well, I just take that power and I write it in front of my logarithm. That is 3 times log base 4 of 2. So what I'm saying here is that if I look at this, what I have is that my base on this is 4, and it needs to equal to some exponential power. And then once I find that, everything times 3. Another example, common log. See, no base, right? Common log. Well, I have the log of 10 to the negative 2 power. I just pull that negative 2 down, so negative 2 times the log of 10. So pause the video and I want you to work 3 and 4. Okay. And these are actually nice. These are some simplistic rules that really help whenever you're dealing with these. There we have. I have 3 times the natural log of x. And for this one, the only thing that's difficult about it, and if it helps visually, log 5 to the 1/3. And that, guys, is two of your rules, your product rule and your power rule. Please watch the publisher videos, critically think and structure your homework, and good luck with your homework.